Welcome back to another episode of helping you place on the AMC 8. And today we're going to be looking at the 2024 AMC 8, problems 6 through 10, starting off with problem 6. Sotogi skated around an ice rink, gliding along different paths. The gray lines of the figures below show 4 of the paths labeled P, Q, R, and S. What is the sorted order of the 4 paths from shortest to longest? So they're asking us to sort the following paths from shortest to longest. So right off the bat, we can tell that path Q is going to be our longest. So let's label that 4. Next, we have to tell whether P, R, or S is going to be our longest. Doing a little bit of investigating, we can see that path S is going to be our 3rd longest. The reason being, for example, let's go ahead and split path S down the middle right here. In order for path S to be shorter than, let's say, path P, then this elbow portion that path S has to be shorter than the straight portion that path P has. But since we know properties of triangles, we know that the hypotenuse, which path P has, always is going to be shorter than the 2 legs, which path S has. That means path S has to be longer than path P. Now finally, all we have to do is tell whether path P or path R is longer. Again, using our properties of triangles, we can tell that this hypotenuse that path R has to be shorter than the 2 legs, but it's kind of curved, but it's roughly equated to the 2 legs that path P has. That means path P is going to be our 2nd shortest, and path R is going to be our shortest path. So, from order of shortest to longest, we have path R, P, S, and Q. Looking at our answer options, we see that our answer is D. R, P, S, Q. Problem 7. A 3x7 rectangle is covered without overlap by 3 shapes of tiles: 2x2s, 1x4s, and 1x1s, shown below. What is the minimum possible number of 1x1 tiles used? Alright, so there's 2 methods to going about this problem. You can either use the competition method, which is a great way to use if you're under time constraints and thinking under a lot of pressure. Or you could use the algebraic way, which requires a little bit of more algebraic thinking, but it's always good to understand the algebra and the math behind any of these AMC problems. So starting off with the competition method, go ahead and block off as many blocks as you can using either the 2x2 or the 4x4. It doesn't matter which one you use since both have the same area of 4. So now that we've blocked off as many as we can, let's just count how many of these 1x1 blocks we need. And so the total turns out to be 5, so our answer is going to be E. Now using the algebraic method, let's look at what the problem is asking us. We have a 3x7 rectangle, so that area is going to be 3 times 7 equals 21. All of our answer options, 1, 2, 3, 4, and 5, are basically the difference between 21 and however many blocks we can cover with the 2x2 or the 4x4, since those are our largest blocks. Well, if we look, in order to get 1, you have to subtract 20. In order to get 2, you have to subtract 19. In order to get 3, 18. In order to get 4, 17. And 5 would be 16. Looking at our options, only 2 are multiples of 4, 20 and 16. 1, after a bit of trial and error, you can tell is not possible. So that means either way, our option is going to be E, 5. Problem 8. On Monday, Tay has $2, Every day he either gains $3 or doubles the amount of money he had on the previous day. How many different dollar amounts could Tay have on Thursday, which is 3 days later? The easiest way to solve this problem is to do a tree graph. So on Monday, Tay started off with $2. The next day, on Tuesday, there are two different options. He could either add $3 and get $5, or double that amount and get $4. On Wednesday, there's 4 different options now, since each of our 2 options have 2 more options. Either add 3 or times 2, that's 8 or 10, same thing over here. And finally, on Thursday, there's going to be 8 options, since it's the options from Wednesday times 2. So you can either have 11 or 16, 13 or 20, 10 or 14, 11 or 16. So we have 8 different options, but if you notice, the problem asks how many different dollar amounts. So let's go through and eliminate all the doubles. We have 11, 16, 13, 20, 10, 14, 11, and 16 again. So we can go ahead and cross off those 2 options. That's going to be 8 minus 2 options. So our answer is going to be D, 6. Problem 9. All the marbles in Maria's collection are red, green, or blue. Maria has half as many red marbles as green marbles, and twice as many blue marbles as green marbles. Which of the following could be the total number of marbles in Maria's collection? So if you look at it, this problem is essentially just an easy algebra problem, so let's break it down. In Maria's collection, she has red marbles, blue marbles, or green marbles. We see from the problem that she has half as many red marbles as green marbles. That means green is equal to 2 reds. And then the problem continues to tell us that she has twice as many blue marbles as green marbles. So that means blue is going to be equal to 2 green. Doing a bit of substitution, we see that blue is also equal to 2 times 2r. Because if we look, we can substitute G right here to get that blue is equal to 4 reds. So now finally adding up R, G, and B, R plus 4R, which equals blue, plus 2R, which represents green, is equal to 7R. Finally, looking at all of our answer options, there's only one that's a multiple of 7. And so our answer is going to be E, 28. Problem 10. In January of 1980, the Mauna Loa observation recorded carbon dioxide, CO2, levels of 338 ppm, which is parts per million. Over the years, the average CO2 reading has increased by about 1.515 ppm each year. What is the expected CO2 level in ppm in January of 2030? Round your answer to the nearest integer. In order to solve this problem, all we have to do is find the number of years between 1980 and 2030, multiply it by 1.51 because that's how much it increases every year, and add it to 338. Let's go ahead and find the difference between 2030 and 1980. That difference is going to be 50 years. 50 years times 1.515, which is how much it increases every year, gives us 75.75. Adding this to 338, we get that the ppA of CO2 in the year of 2030 is going to be 413.75. Rounding this to the nearest integer, we get that our answer is going to be B, 414.